Hello all, welcome to this session. In this session, we will start with the B-type instructions in Risc-V. So B-type instructions in Risc-V are used for conditional branching. So we have discussed about R-type instructions, register instructions, and I-type instructions, that is immediate type instructions in Risc-V. So this is another type of instructions which are present in Risc-V. Those are called branch instructions or B-type instructions. So these are used for conditional branching. So they basically what they do is compare two registers and branch to a specified instruction if the comparison is true. So uh, the values will be present in two registers. We have two source registers, right? RS1 and RS2. So the values will be present in the two registers, RS1 and RS2. The comparison will be happening between these two registers, uh, whether it may be greater than comparison or less than comparison or equality comparison or anything. So the any kind of comparison, we will see what type of comparisons which we have in this branch type of instructions. So the comparison will be performed, any type of comparison will be performed according to the opcode. And so if the comparison is successful, then the branch will be, or the program counter PC will be pointing towards the address which is specified in the instruction. So we have discussed in our previous sessions also, right? So program counter will actually point towards a specific address in the instruction memory. So this is our instruction memory. All the instructions will be stored inside this instruction memory, and the counter will point towards the particular address 0, and it will move to the next address, that is +4. So like this, it will go to the particular address and it will uh, fetch the instructions from the instruction memory, right? So like this, our instructions will be fetched with the help of this program counter. So it is basically a pointer which is pointing towards the address locations. So what happens is, if the comparison is successful between these two registers, then this program counter will point towards the address which is specified in this instruction itself. Okay. So B-type instructions use a specific instruction format that includes fields for the opcode, source register, the branch target offset. This basically this branch target offset. The If the comparison is successful, the address which is given inside this branch target offset. So according to this address, this PC will be pointing towards. Okay. So this is the basic format of B-type instruction. So a opcode will be present as which is present in previous instructions, or also R type, I type. So in B type also opcode will be present. So this is used to indicate the instruction type, and function 3. So which is used to indicate the type of the comparison. Okay, what type of comparison we are doing? This function 3 is used to tell us. And RS1, so this is of 5 bits. This is source register, and RS2, this is also 5 bits. This is second source register, and immediate of 12 bits. So we will have immediate 12 bits. So the immediate value used for branch target address, split into multiple paths across the instruction. So in this instruction, immediate value will not be present. 12 bits will not be present at only one location. So it will be spread into different parts in the instruction. We will see the instruction. So like this immediate value will be provided. The address will be provided. So these are the different types of instructions which are present in this B type. So this is B equal and B not equal, B less than, B greater than, B less than unsigned, and B greater than unsigned. So the opcode is same for all the branch type instructions. The opcode is 11000011. This is same for all B type instructions. And according to the function 3, there will be differentiation. That is, it is branch equal to, or branch not equal to, or if it is 100 it is branch less than, or if it is 101 it is branch greater than, or if it is 110 it is branch less than unsigned, and if it is 111 it is branch greater than unsigned. Okay. So coming to branch equals, the description we will see. So in case of branch equal, if branch if the values in two source registers are equal. So the values which are present inside RS1 and RS2 are equal, then this program counter PC will point towards the address which is specified in the instruction. Or So if it is not equal, that is RS1 is not equal to RS2, what happens? Then PC will increment in its default way, that is PC is equal to PC plus 4. Like this, the increment will be happen. So if RS1 is equal to RS2, then what happens? The program counter will point towards the address which is provided in the immediate value. Okay, so like this, the branch equal to instruction works. Next, in case of branch not equal to, what happens? In case of branch not equal to, if RS1 is not equal to RS2, what happens? Then the program counter will point towards the immediate value. That is the address which is provided by the immediate value. The program counter will point towards that address. Whereas if it is equal, then program counter will not point towards the address which is specified in the immediate value. It will do its normal operation. That is PC is equal to PC plus 4. It will just point towards the normal. It will increment normally. Okay. Next, same BLT, that is branch less than. So if the value in RS1 is less than the value in RS2, then the program counter will point towards the address which is provided in the immediate value. Else, it will normally increment and it will point towards the address which we have got after incrementing PC plus 4. Okay. Next, if it is, let me show it is it in a diagrammatic way. So let's say this is our instruction memory. So let's see this B equal to operation where RS1, if RS1 is equal to RS2, then in immediate value, let's say we are providing a offset address 4. Okay, let's say we are providing 4, or let's say we are providing 8. Okay, so PC program counter, what it will first, it will point to address 0. Next, it will go to address 4. Normal PC operation is PC is equal to PC plus 4. That this program counter will be incremented 4 for every clock cycle. Okay. So it will go to the fourth address location and it will fetch the instruction from this fourth address location outside this instruction memory. And it will go to the address location 8 and it will fetch the instruction which is present in this 8th location. Okay. Like this, it will keep on fetching. So not only this 0th location, 4th location, 8th location, it will fetch the instructions which are present in 0 followed by 1, 2, 3. Basically this 0 is the base address and it will come to 4. So from 4 to 4, 5, 6, 7, the instructions it will fetch this. So the instructions which are present in this particular address locations 4, 5, 6, 7, it will fetch. Okay, so this will be happening internally. Externally, what we'll see, the PC will be pointing towards 0 and next it will be pointing towards 4 and next it will be pointing towards 8. Like this, it will be pointing. Now if branch instruction is given, so what happens here in 8th location, if it see this branch instruction and it encounters that BEQ is equal to 1, branch equal to is equal to 1. So what happens? The immediate address in the immediate value, the address will be provided, right? So what is the address here provided? 8. So the PC will, what it will do, instead of going to 8 plus 4 12, it will go to 8 plus 8, that is 16. So it will go to the address location 16. Okay, like this, it will go and fetch the instructions from the instruction memory. So if the particular condition, if the particular comparison operation is successful, then the program counter will go to the particular address which is specified in the immediate value. So like this, there are different types of comparison operations in the B type instructions, and if the particular comparison operation is successful, then the program counter will go to the specified address location which is present inside this uh, immediate value. Okay, so let's see this branch equal to instruction. So in case of B equal to instruction, so it is a conditional branch instruction used in Risc to control the flow of a program. It compares the values in the two source registers, and if they are equal, it branches to a specified target address. So the B equal to opcode we have seen, and function 3 it consists, and RS1, RS2, and immediate value also it consists. Immediate value is consisting of address. Okay. The target address calculation. So target address is equal to PC plus immediate address. that is the target address the PC will be pointing towards. Okay, this also we have see. So this is the instruction format of branch equal to instruction b equal to x5 x6 label. So this label we will provide the immediate value, that is offset value, immediate value or offset value we will be providing. Okay. So this is the introduction to branch instructions in RISC-V processor. So I hope it is clear. So in next session, we will see in more detail about each instruction, and we will see how the immediate value is spread over the instruction. Okay. So that's all for this session. Thank you.